Howdy, this is Abraham and this is Kinetic. So what Kinetic is an application that can take you from a baseline idea to a full machine learning implementation solution, right? Now, what this means is you can come to us with just some data and a problem you want to solve, and we'll take you from there all the way to its machine learning solution, right? Now, how do you actually do this? So let's get started. You first start off here where you first sign in. Now, once we sign in, we'll get to where the actual sort of fun stuff happens is the dashboard. How we first start off is by creating a compute workflow. And what this is we'll be running all our different computes to solve this problem, right? In our case, we'll just say cancer model. And the reason I'm calling it this is because I sort of have this example that I want to show off, which is let's say you're a doctor and you have this data on cancer and you believe it could help you identify breast cancer, right? But you're not 100% sure, right? And you're not a machine learning scientist, nor are you a data scientist. So you can't exactly go out there yourself and sort of try to implement all this. That's where we come in to sort of take you from having your data and your idea to actually having a full machine learning solution. Now, how is this done? The first thing you do is you upload your data, in this case being a CSV. However, we do accept other formats such as zip. And additionally, you provide just a sort of simple explanation such as build a breast cancer detection model. All right. Now, once we have our sort of big idea alongside our data, we can press on the generate button. And what this does is it takes sort of any context that we've given it alongside sort of the data we gave it, and it combines all this to come up with a wide variety of models that it can then use to try to solve the problem, which we'll see in just a moment once it finishes, right? Which it just has. So we'll go into launch training. Now here we can see it decided to try using a gradient boosting model, a logistic regression, and a random forest. Now what we're seeing here is the different models training on our Vultr servers. And as you can see, all models came out successful. And now once we're in the actual results page, how this all works is you can see we have different evaluation metrics, test accuracy, training loss. And something I did want to mention is it may seem a little baseline level. However, the reason it is that way is because we wanted to make sure to have a consistent sort of output from the actual Nemotron model, meaning we sort of put this sort of really baseline sort of metrics to make sure we could not only have a consistent output, but also have the opportunity to compare these models and really be able to understand how do they compare and say loss, comparison, training time, and just different features, right? And one last thing we did add to it was a little sort of LLM feature here where you can sort of ask it like, what are some other evaluation metrics for random forest? And all this is you sort of just trying to gain a better understanding of the model, right? And that's there you can sort of read it and understand a little more. And thank you so much and gig 'em.